we shall take up studies on chemical kinetics, and there are certain important reactions, and these reactions are termed as pseudo first order reaction and zero order reaction. ये बड़े इंटरेस्टिंग रिएक्शंस हैं कि जीरो ऑर्डर रिएक्शन क्या होता है और pseudo फर्स्ट ऑर्डर रिएक्शन क्या होता है. Pseudo का मतलब ये कि ऊपरी रूप से apparently they appear to be a reaction of a different order even if they follow first order kinetics. ऊपर से देखने में ये लगता है कि ये बाईमॉलिक्यूलर हो सकता है, सेकंड ऑर्डर रिएक्शन हो सकता है, बाईमॉलिक्यूलर तो खैर है ही, और लेकिन वो फर्स्ट ऑर्डर रिएक्शन होता है. और ये ऐसा इसलिए होता है कि देयर इज सर्टेन सेट ऑफ कंडीशंस व्हेन दिस सूडो फर्स्ट ऑर्डर रिएक्शन टेक्स प्लेस. अब इसके लिए हम आपको पहले एक एग्जाम्पल बताएंगे और उसके बाद उसकी कंडीशंस को बताएंगे कि कब ये सूडो फर्स्ट ऑर्डर रिएक्शन फॉलो करता है और सूडो फर्स्ट ऑर्डर रिएक्शन किस प्रकार से होता है, इसके बारे में हमें जानकारी होना है. और there are certain points which I have already provided to you, and these are here. For example, there is a reaction between methyl acetate CS3COOCS3. This is known as methyl acetate. When hydrolyzed in acidic medium in presence of an acid, and of course excess of water is taken, large excess of water is taken there. अगर दो रिएजेंट्स में से एक रिएजेंट ऐसा है जो कि बहुत ज्यादा अधिक मात्रा में है, उसका कंसंट्रेशन ज्यादा है, और ये एक अच्छा एग्जाम्पल है सूडो फर्स्ट ऑर्डर रिएक्शन का. अब ऑफ कोर्स यहाँ पर देखने में लगता है कि ये बाईमॉलिक्यूलर रिएक्शन है, और एक्चुअली इट इज ए बाईमॉलिक्यूलर रिएक्शन because there are two molecules which react together to form acetic acid and methanol, methyl alcohol. But what happens here that due to large excess of water, one of the reagent, its concentration does not change substantially. It remains almost the same, and therefore it follows first order kinetics. तो ऐसे केसेस में फर्स्ट ऑर्डर रिएक्शन होता है, जबकि दो रिएजेंट्स में से या दो रिएक्टेंट्स में से एक रिएक्टेंट काफी अधिक मात्रा में लिया जाए. Another example is there, that is hydrolysis of cane sugar in acidic medium in presence of an acid. So these are hydrolytic reactions which represent pseudo first order reaction. Both the above reactions are first order reactions. The concentration of water as one of the reactant remains almost unaltered due to large excess. क्योंकि बहुत अधिक मात्रा में है, एसिडिक मीडियम में वाटर का बहुत अधिक मात्रा में होना, बहुत अधिक कंसंट्रेशन में होना, उसके कारण इसके सांद्रण में कोई फर्क नहीं पड़ता, और इसलिए it is regarded, even though it is a bimolecular reaction, it is regarded as first order reaction. तो apparently ये first order नहीं दिखता, लेकिन है फर्स्ट ऑर्डर रिएक्शन, एंड दिस इज ए बाईमॉलिक्यूलर रिएक्शन. अब इसको अगर हम जनरलाइज करें, वो तो हमने पहले आपको उदाहरण दिया है. अब मान लीजिए एक रिएक्शन A plus B, C and D is there. If one of the reactant is present in large excess, for example, in this reaction, if B is present in large excess, we call this reaction as the order with respect to A is 1, and the total order of the reaction, क्योंकि B के concentration में कोई फर्क नहीं पड़ेगा, large excess में है, total order of the reaction is 1. इसका उल्टा भी हो सकता है, जबकि हम A ज्यादा excess में हो और B का सांद्रण निश्चित रूप से कुछ होगा, तो अगर A large excess में है तो A का A raised to power 0 हो जाएगा, and it will follow a first order reaction kinetics. So this is how we can understand in a general way. And the examples usually are the hydrolysis of cane sugar and hydrolysis of esters in acidic medium. That is what we have taken up. Now next we get into what is given in your book. This is also equally important in your CBSE book. It is Unit 4 Chemical Kinetics, and a portion about pseudo first order reaction is here. इसको भी आप अगर ठीक से अध्ययन कर लेंगे, समझ लेंगे, तो pseudo first order reaction को समझने में भी सुविधा होगी. We'll feel convenient to go through it. And ये बहुत अच्छा उदाहरण यहाँ पर दिया हुआ है. यहाँ पर ethyl acetate hydrolyzed with in acidic medium forms acetic acid and ethyl alcohol या ethanol. अब मान लीजिए 0 टाइम पर 0.01 मोल इथाइल एसिटेट था और 10 मोल्स ऑफ H2O या वाटर है, तो इसके कंपैरिजन में वाटर की मात्रा बहुत ज़्यादा है एसिडिक मीडियम में, और ये 0 मोल्स तो प्रोडक्ट तो शुरू में तो 0 रहता ही है. आफ्टर टाइम t सेकेंड्स ये 0 मोल हो सकता है इथाइल एसिटेट, लेकिन H2O के सांद्रण में कोई फर्क नहीं पड़ा. इट इज ऑलमोस्ट 9.9, मतलब करीब करीब उतना ही है. एंड देयरफॉर इफ यू राइट ए rate equation, we can write that rate is equal to K dash ethyl acetate into concentration of water. Concentration of ethyl acetate into concentration of water, and we put the constant as K dash. Now this concentration of water here remains almost the same, so we can say that this is a constant, and therefore we can write that enter a new constant, that is K ethyl acetate, CS3COOC2H5, where K is equal to K dash into concentration of water, which is almost the same, and the reaction is a first order reaction. Such reactions are called pseudo first order reaction. This is a very good example, and ये केन शुगर का उदाहरण तो हम आपको पहले ही बता चुके हैं. This is also given in your book. Please go through this unit also. 4.4 pseudo first order reaction. Now next we get into something else about pseudo first order reaction. तो ये देखिए यहाँ पर जो चीजें हमने मार्क की हैं, these are the points which we need to take care. Then we get about the zero order reaction. What is zero order reaction? Means the concentration term should be raised to zero. Suppose there is a reaction. ये भी आपकी बुक का है, CBSE बुक्स में बहुत अच्छी तरह से समझाया है, and that's why I have taken it first, that if a particular reactant forms product, then rate will be written as minus dr upon dt, K raised a concentration of R raised to power 0, and anything raised to power 0 is equal to 1. So we can modify it. Any quantity raised to power 0 is unity. So rate will be equal to minus dr upon dt K into 1. And on simplification, we get dr, that is concentration of R, is equal to minus K dt. अब अगर हम इसको इंटीग्रेट करें तो एक इंटीग्रेशन कांस्टेंट I लगा देंगे, and where I is the constant of integration. At T0 the concentration of reactant R is equal to R0, मतलब जो कोई टाइम स्टार्ट में शुरू में T is equal to 0, मतलब शुरू में R is equal to R0, where R0 is the initial concentration of the reactant. और उसको जब हम यहाँ सब्स्टिट्यूट करेंगे, we get the final equation as R is equal to minus KT R naught. R naught means the initial concentration. अब यहाँ पर ध्यान देने की चीज ये है, the unit of rate and rate constant is same in zero order reaction. Very important here, rate और rate constant का unit वही होगा और होता है. अब इसके आगे थोड़ी सी हम और चर्चा करेंगे. वो देखेंगे कि अगर हम टाइम को कंसंट्रेशन के अगेंस्ट प्लॉट करें, यू गेट ए स्ट्रेट लाइन with a slope which is equal to K, and this is quite important. This is a negative slope is there, और इसी को हम फर्दर इस प्रकार से लिख सकते हैं that K is equal to R naught minus R upon T. R naught is nothing but the initial concentration, and R is the concentration of the reactant at time T. So such reactions are very common, and In presence of an enzyme, these reactions take place. Enzyme. Then next we get more idea, and that is here K is equal to R naught minus R upon T is quite important. Zero order reactions are relatively uncommon. Some enzyme catalyzed reactions and reactions which occur on a metallic surface are zero order reaction. For example, ammonia gas, when heated at a temperature of 1130 degrees on platinum catalyst, then what happens? A reaction takes place at the catalytic surface, and that is a zero order reaction, and this represents decomposition of ammonia gas forming N2N3H2. In this case, platinum metal acts as a catalyst. So that's there. Now, next we get the same thing. An equation of the zero order is represented like this. And at half-life period, we can calculate T half is equal to R naught upon 2K. The half-life for the zero order reaction is inversely proportional to its rate constant. ये बहुत इंपॉर्टेंट है. हाफ लाइफ पीरियड जीरो ऑर्डर रिएक्शन का रेट कांस्टेंट के इनवर्सली प्रोपोर्शनल होता है. And here are certain mathematical simplifications for half-life in zero-order reaction. Next, now let us have some practice questions to clear up our understanding about zero-order reaction, the first-order reaction, and also certain other questions relating to chemical kinetics. We shall take up only 3 questions today. The first question is, zero-order reaction takes 100 minutes for 50% completion. How much time in minutes it would take to complete 75% of the reaction? Now, since there is a linear relationship with the concentration and the time taken, therefore, the correct answer in this case will be option C, that is 150 minutes. Next question, the unit of rate and rate constant is the same for, as we have already learned, a zero order reaction would be the right answer here. It's the first order and second order and third order reactions will not have the same rate and the rate constant units. Now, third question, of course, very important. For a reaction A being changed to B, A is the reactant and B is the product. The rate law is given by rate is equal to K concentration of A. The initial concentration of A is 2.0 m, and after 10 seconds, the concentration of A decreases to 1.0 m molar. The half-life period of the reaction is being asked here, and therefore we need to perform certain calculations based upon a few steps. The first step is calculate K, and for first order reaction we know that K is equal to 2.303 log upon T log A upon A minus X. Our concentration, initial concentration, or the concentration at time T. So that equation or expression is known to us, and when you apply here, putting up the values and simplify, you get K equal to 0.0693. Second inverse, of course. The unit is not shown here. The second step, from that we can calculate half-life period, that T half is equal to 0.693 upon K, and that comes out to be 10 seconds. So option C is the correct answer in this case. Okay, thank you. Please do subscribe to our channel and go through the details provided here regarding chemical kinetics. Thank you very much.